Hello, Calculus student. This is lesson 1, Calculus 1 review. In the first video, I'm going to go over the Calculus 1 derivative function and integral functions notation, differentiation formula, integral formula that you should be well versed of, and how to find equation of a tangent line and using definite integral to find area between two curves. I will also briefly go over U substitution, but in this video, I'm not going to do example. The example will be in the second video. This would just be an overall topics that you should have known from Calculus 1. Okay, so from the beginning, we would look at notation. So Calculus 1 has two main topics. One is derivative, the other is integral. So we are going to talk about integral, the derivative notation. So the derivative function, if you are given f of x is f prime of x, second derivative is f double prime, third derivative is f3 prime, fourth derivative is f4 of x, etc. And technically, you can have f4, fn, where n is in integers, of x. So this is not, typically we actually bracket it. Okay, so I think I should bracket it in your notes. So this is not the function to the power 4. So prime or bracket with a number means derivative. And if you want to plug in x equal to a in all of these, so it will be f prime of a. This means you do f of x, f prime of x, and then plug in a, etc. So f n derivative of a. And then for differentiation operation as an operation, usually we would use dy dx also. On the second derivative will be d squared y over dx squared. So dx squared is not about x squared. It's just the second derivative of y with respect to y. And then technically you can have dny dx to n. And if you have to plug in x equal to a for the dy dx, you would do the dy dx formula and then do a slash x equal to a. A lot of time when we do derivative, we need to rewrite our x that is in radical exponent or 1 over x exponent into a x to the power n notation. So the rewriting would be if you have 1 over x to the n, it would equal to x to the negative n. If you have square root of x to the, not square root, n root of x to the m, it will be x to the m over n. And in particular, if you just have the n root of x, that will be x to the 1 over n. Okay, so the numerator is an exponent of x. The denominator is specifying the root. So if I have square root x, that would be written as x to the power 1/2. If I have cube root of x, that would be rewritten as 1/3. And if I have 1 over square root of x, it will be rewritten as x to the power negative 1/2, etc. 1 over x squared can be rewritten as x to the power negative 2. Okay, so you need to be well versed on this rewrite and changing radical into exponent and exponent into radical. So the next thing is about derivative differentiation or derivative formula. The main thing is power rule. d dx x to the n is n x to the n minus 1. And d dx of x, which is x to the 1, would equal to 1. And d dx of a constant, which is like k is a constant, would be 0. So we can add these two. Then the trig derivative would be derivative of sine is cosine, but derivative of cosine is negative sine. So for tangent and secant square, all these you need to be well versed of it. You need to memorize them. The more useful one are tangent and secant. In chapter 3, we will use these, the first 4 heavily. Exponential and log, we have d dx of e of x is e of x, d dx of ln x is 1 over x. And we will talk about when it is not a natural log base, but b to the x. But here is the formula, is ln b to the x. And then if you do log, is 1 over x ln b. For inverse trig functions, so for arctangent, it become actually a rational function, 1 over 1 plus x squared. So -1 does not mean 1 over sine x. It means the inverse trig function. So arcsine, arctangent. So they are listed like this. You also need to be well versed of it, especially the arctangent and arcsine. Other than these derivative formula, you also need to know product and quotient rule. The product rule is if you have a f and a g function multiplied together, you will do the derivative as the derivative formula is fixed f first, and then do a derivative of g plus fixed g, and then do a derivative of f. And if it is a two function divided each other, it will be g f prime minus g prime f. That means you write g and then d dx of f minus g prime d dx of g times the numerator. Okay, chain rule. Chain rule is when it is not multiplying, is you have a function inside a outer function. Like, for example, square root of x plus 1, your inside function is x plus 1, your outside function is square root x. Or sine x to the 4th, your inside function is x to the 4th, your outside is sine x, but sine square x is different. Sine square x, the outside function is square, the inside is sine x. So if you have function like this, they are not product or quotient, they are function composite. So then you would do the derivative of the outside function, keeping the inside function constant, and then do a ddx of the inside function, multiply them. Integral formula, integral is similar to antiderivative, and I will give you a integral card that you can pick up from the math lab. I'll pass you a copy. So these are the one that you know, which basically is the reverse of what the derivative formula is. For power rule, x to the n would be xn plus 1 over n plus 1, except n cannot be -1. When n is -1, that means 1 over x, your derivative is, your integral is ln absolute x. Then for cosine, sine, all of those are just the opposite of what your derivative function is. Just pay attention to integral of sine x. Oh, I think I'm missing some dx. Yeah, so sine x dx, secant x dx. Yeah, I'm missing all of those. So they are that for integral sine x is negative cosine x. Pay attention to this. For exponential and log, integral of e of x is e of x plus c. Integral of 1 over x is ln, but absolute x. We'll explain this in 2.7. For the antiderivative of inverse trig function, we will have a squared plus u squared instead of 1. We'll have a. And just pay attention to the fact that they will have to be multiplied with 1 over a, u over a, except for sine inverse. There's no 1 over a outside, just u over a plus c. I think I add plus. I'm missing plus c here also. And yeah, so just pay attention to how to do them. And then for the u substitution, you should have learned some u substitution. The simple one is if you do a sine x kx or cosine kx, it will be negative cosine kx over k. So this is kind of like the reverse of the chain rule. For e of kx also is over k plus c. You also need to know how to find tangent line equation. Tangent line equation is when it is an a f of x, because a is at the original f of x function, then the slope would be a prime of a, right? So if you use the point slope form, y minus y1 equal to m open x minus x1. So you would write the formula like this. And if, in case you want to write y equal, typically we would write it this way. Y would equal to f of a plus f prime of a x minus a. And you'll see that in chapter 6, we will extend this to approximate a function using higher level exponent, polynomial. Okay. Use integral or finding area under a curve of f of x would be f of x dx. F of x dx. If the f of x has to be above the x-axis, if it's below the x-axis, this definite integral would find net area. So for f of x positive, right? And for all areas, so you would have net area. Net area means the area under x-axis is negative, would be AB f of x dx with no restriction. So you would allow f of x to be below it, but you would have a net area where area under the denominator under the x-axis is negative. So you would end up having, for example, okay, so for example, if your f of x is like this, your integral of AB would be this area minus this, or add a negative of the area like this. U sub for integral. So a lot of time when we do integral, you really have to use the integral formula. There is no product rule. There is no quotient rule. And there's so the U sub is actually a reverse of the chain rule, where if you see your function inside of integral as f of gx has an inside and outside, but the outside is f prime of x dx, then maybe you can change it into f of u du. So replace this by u and then replace this by du. Replace this at f of u, and then hopefully this will be a more simple integral that you can use the integral formula for. So basically you need to do a substitution. And when you are doing a definite integral, your AB, if it is AB f of g of x, but for some reason your outside has a g prime of x dx, then you can change this to g of b. G of A, you replace everything as f of u and then du, because this is u. Okay, so in the next video, I'll go over a few examples of integral and derivative, and then we'll do another video on u substitution and also tangent line.